So last class we discussed about the radial type of primary feeder, radial type primary feeder, and also connection scheme of the distribution system. In radial type primary feeder, again improvement, that is sectionalized tie switch, express feeder and back feeder, and also area feeder, loop feeder. So now we go for the next topic, that is the methods of solving AC distribution system or methods of solving AC distribution problems. So same topic will be held in the fourth unit also. So just name change, manual methods of voltage calculations, same ditto. Generally, in case of DC system, the voltage drop is due to only resistance, right? Already we discussed in the difference, AC DC difference in differences. In DC system, the voltage drop is due to only resistance. However, in AC systems, voltage drop is due to resistance and reactance. Reactance may be inductive reactance or capacitive reactance, whatever it may be. So now, suppose in DC system, addition and subtraction of current and voltages are done in arithmetically, but here vectorically you have to done in the AC systems. So in an AC system, power factor to be taken into account. Therefore, the loads tapped off from the distributors are generally at different power factors. One consumer may consume more power at that time, so their house will operate with one type of power factor, whereas in another consumers, so that means every consumer having its own power factors. In AC distribution calculations, power factor of various load currents may considered as a distributors in different manners. So now the power factor of load current may be given in, otherwise the power factor of load current, that is nothing but every consumer, may be expressed or may be calculated in two ways. First one is power factor referred to receiving end voltage. Second one, power factor referred to respective load voltages. So mainly in DC system there is no power factor. In AC system, power factor is considered. Every consumer having their own power factor. That is the main problem. So that's why, so you have to calculate every consumer voltage drop. So to calculate that different consumer voltage drops, two methods are available: power factor referred to receiving end voltage, power factor referred to respective load voltages. Receiving end voltage is nothing but consumer voltage. Depending upon the consumer voltage, we have to calculate the voltage drop. And power factor referred to respective load voltage is nothing but total voltage, total load voltage. We have to calculate according to total load voltage, and we have to calculate only receiving end voltage. కన్జ్యూమర్ వోల్టేజ్ని అనుసరించుకొని మనం క్యాలిక్యులేట్ చేస్తాం, అదేవిధంగా టోటల్ లోడ్ వోల్టేజ్ని అనుసరించి చేస్తాం. సో ఫస్ట్ పవర్ ఫ్యాక్టర్ రెఫర్ టు రిసీవింగ్ ఎండ్ వోల్టేజ్. సో జనరల్లీ look at the picture. Let us consider a AC distributor. The AB concentrated loads. So this is the distributor. AB is the distributor, and from the in the distributor itself, tappings are available, right? So C one tapping, B one tapping. So I1 current and I2 current are the tapped currents at point C and point B respectively. and taking receiving end voltage. What is here receiving end voltage? B is the receiving end voltage, not A, not C. So A is nothing but sending end. We have to send the voltage like this. This is the Vs, sending end voltage, and this is B is the receiving end voltage. So take the receiving end voltage VB as the reference vector. At lagging power factor at point C and B, we cos pi 1 cos pi 2. At C the power factor is cos pi 1, at B power factor is cos pi 2. Why? Because this is one individual consumer, this is one individual consumer, right? So they will operate their own power factors, individual power factors. Let R1 X1 and R2 X2 be the resistance and reactance of section AC, section CB or BC of the distributor. Resistance of the section, resistance of the sections, reactance of the section, reactance of the section, right? First of all, we have to calculate impedance. Per particular section we have to calculate impedance. Then per particular section we have to calculate current, right? After then per particular section we have to calculate voltage drop. First Z, next I, next V. So V is equal to IZ, voltage drop is closed. Like that we have to remember the given problem. First of all we have to find out impedance of each section, and then find out current of each section, and then find out voltage drop of each section is nothing but multiplication of voltage and impedance. On total sending end voltage is nothing but VA is nothing but so VAC plus VBC plus VB. Why? Because so with respect to the receiving end voltage, so this B is the receiving end voltage, right? That's why we have to calculate like this. So first impedance of section AC, that is equal to ZAC, right? So like here this is the vectorical, so vectorical calculation, that's why putting bar ZAC equal to, we know that they given R1 plus JX1, right? So impedance of section AC ZAC is equal to R1 plus JX1. Impedance of CB R2 plus JX2, right? Now load current at point C, right? I1 bar, we know the formula, I1 bar equal to I1 cos pi 1 minus J sin pi 1. Generally it is expressed in e power j theta, e power minus j theta. So that is cos theta minus j sin theta. Like that I1 current at C is nothing but I1 bar is equal to I1 cos pi 1 minus j psi pi 1. Next B, the current at B, I2 bar is equal to I2 into cos pi 2 minus j sin pi 2. So just we find out current at points. Now current at sections, current at section CB, current at section CB is nothing but, that is nothing but I2, right? So from this CB I2, సో ఈ కంప్లీట్గా కరెంటు I2నే మళ్ళీ ఇక్కడ మళ్ళీ వేరే బ్రాంచ్ కానీ ఇస్తే ఇంకొక కన్జ్యూమర్ సపోజ్ ముగ్గురు క్యాలిక్యులేట్ చేయాలి. సో 3 కన్జ్యూమర్స్ క్యాలిక్యులేట్ చేయనప్పుడు I1 I2 I3 at that time, so CB current is not equal to I2, but there is no extra consumers and B is the dead end. That's why the current is flowing, that B is nothing but branch current also this one. So current in section CB is nothing but I2 cos pi 2 minus j sin pi 2. Current at section AC, so this already I1 is there plus I2, I1 plus I2, that is I1 cos pi 1 minus j sin pi 1 plus I2 cos pi 2 minus j sin pi 2, right? We have to find out impedance for every section, we have to find out current at every section. Now find out voltage drop at every section. Voltage drop in section CB, VCB is equal to ICB into ZCB. ICB I2 cos pi 2 minus j sin pi 2, ZCB R2 plus JX2. Section AC IAC ZAC, I1 plus I2 ZAC. So like this. Now sending end voltage. So VAC plus VCB plus VB, right? Like that you have to determine the voltage drop of each section or every consumers. And see the vector diagram. Already I am telling VB as reference. That's why we have to add the VB extra. So first VB taken as VB as reference, right? VB means next ఒకసారి ఈ డయాగ్రామ్ చూడండి. ఈ డయాగ్రామ్ చూస్తే ఇంకా సో తెలిసిపోద్ది VB రెఫరెన్స్. సో VBకి ఏమి యాడ్ అయితే ఇక్కడ VC వచ్చింది I2 R2 ప్లస్ I2 J I2 X2 యాడ్ అయితే VC వస్తుంది. VBని నేను రెఫరెన్స్ తీసుకున్నాను. ఇప్పుడు నాకు VC దగ్గర వోల్టేజ్ రావాలంటే ఆ VB వోల్టేజ్కి ఇదిగో ఈ డ్రాప్ I2 R2 ప్లస్ I2 JX2 ఈ రెండు డ్రాప్లు యాడ్ చేస్తే నేను VC వస్తుంది. ఈ VCకి మళ్ళీ నేను I1 R1 I1 JX1 యాడ్ చేస్తే నాకు సెండింగ్ ఎండ్ వోల్టేజ్ వస్తుంది. జస్ట్ ఈ డయాగ్రామ్ గుర్తుపెట్టుకుంటే ఇది డెడ్ ఈజీ. VBకి ఏం యాడ్ చేయాలి? I2 R2. రెసిస్టెన్స్ అనేది ఎప్పుడు కూడా కరెంట్లోనే ఉంటుంది. I2 అనేది ల్యాగింగ్ కాబట్టి ఇదిగో ఈ విధంగా I2 ల్యాగింగ్ pi2 యాంగిల్ అండ్ I1 pi1 యాంగిల్. వాటి రెండింటి యొక్క I1 plus I2 vectorically how to combine. Now VB is the reference and I2 R2 is in phase with I2, that's why I am writing like this. I2 JX2, so 90 degrees, so like this. So VB plus I2 R2 I2 JX2, what you are getting? VC. Now VC I1 R1 not I1, IAC. Why? Because I1 plus I2, right? IAC R1, IAC X1, we are getting VA. So just from this diagram we can draw easily vector diagram. VB is the reference and to add the drop I2 R2 J I2 X2, then we are getting VC. Then we are adding IAC R1 IAC X1, then we are getting VA. That is the vector diagram. So నేను ఇమేజ్ కొంచెం పెద్దగా పెట్టాను, మీరే అంత భయపడిన అవసరం లేదు, రైట్? నెక్స్ట్ లైక్ దట్ యూ హ్యావ్ టు డిటర్మైన్ ది voltage drop of each consumers. Next one, power factor referred to respect to load voltages, total load voltages. Total load voltage is nothing but individual consumer having their own power factor, total load voltage having their own power factor. That is nothing but the difference between these two power factor, first we have to calculate it. This one alpha. So once we have to calculate alpha, remaining same ditto previous one. Why? Because previous one we have to calculate the individual consumer power voltage drops. Suppose Sesi house voltage drop, Chanakya house voltage drop, Mohan Reddy house voltage drop are calculated individually. First we have to calculate impedance, then current, then voltage drop. That is the first one, that is completed. Now what is the second one? Power factor referred to respect to load voltage is nothing but these three persons, Sesi, Chanakya, Mohan Reddy, they are calculated individual voltage drops. Now we have to calculate total load voltage, combined load voltage, three members load voltage. So now their three individual power factors and combined power factors, we have to differ. Theta 1 minus theta 2 is nothing but alpha. So now this one we are getting the theta 1 theta 1 minus, sorry, pi 1 minus alpha, pi 2 minus alpha. Then we are getting the respective load voltage. Pi 1, pi 2, pi 3. Sesi, Chanakya, Mohan Reddy power factors are calculated individually. Now we have to calculate alpha. That alpha is nothing but total 3 members load voltages. Now we have to calculate voltage drop is nothing but pi 1 minus alpha, pi 2 minus alpha, pi 3 minus alpha. Then easily find out. Just that is the only difference. First we have to calculate individual, then we have to calculate total load, then subtract, then we have to calculate the voltage drop. Right? So as usual, total. So like this. VB drop in section CB, that is VC alpha. This is the total load voltage angle. Now I1 at an angle minus pi 1, I1. Now we have to subtract, right? Pi 1 is the individual, alpha is the total load voltage. That's why pi 1 minus alpha. So cos of pi 1 minus alpha is nothing but cos pi 1 minus alpha minus j sin pi 1 minus alpha. Like that, first we have to calculate. So this one, pi 1 minus alpha, that is the only difference. I2 there is no change. Voltage drop in the section CB is similar to the, first we have to calculate. So I am putting directly last equations. Why? Because this is also similar to the that one. First calculate impedance, then calculate current at each section. After then calculate voltage drop each section. So current at each section, that is the important one. So we have to subtract the load power factor value with individual power factor. Then we are getting this one, I1 plus I2. Then IAC, ZAC. Voltage at point A is nothing but voltage drop, receiving in voltage plus drop in CB plus drop in AC as usual. Look at the problem, very, very important problem. This problem is related to the first one, power factor referred to receiving end voltage, right? So a single phase AC distributor AB 300 meters long is fed end A and is loaded as under 100 ampere at 0.70 power factor, lagging 200 meter from the point A. 200 amperes at 0.8 power factor, lagging 300 meter from point A. The load resistance and reactances of the distributor is 0.2 ohms, not watt. This is ohms, and 0.1 ohms per kilometer. Calculate the total voltage drop in the distributor. Load power factor referred to voltage at the far end. Far end is nothing but receiving end voltage. So power factor at receiving end voltage. So that is nothing but first part. So what is it given? AB. The total length is 300 meters. Distributor length is 300 meters. But 200 meter దగ్గర పాయింట్ ఏ నుంచి 200 మీటర్ దగ్గర ఒక కరెంట్, ఒక ట్యాపింగ్ ఉంది. ఒక కన్జ్యూమర్ కరెంట్ తీసుకున్నాడు, దట్ ఈజ్ 100 యాంపియర్స్ తోటి. కాస్ పై ఈజ్ ఈక్వల్ టు 0.707. వాట్ అబౌట్ సైన్ పై? దట్ ఈజ్ ఆల్సో 0.707, రైట్? ఇక్కడే మనం ఆ కిందే రాసుకుంటే సైన్ పై కూడా మీకు ఈజీగా ఉంటుంది. నెక్స్ట్ 200 amperes at 0.8 power factor, 300 meters. 300 meters is nothing but dead end, that is this one, B దగ్గర. I2 is equal to 200 amperes, 0.8 power factor, right? Now first and resistance and reactance of the distributor is 0.2 plus j 0.1 ohm, right? But 0.2 and 0.1 ohm per kilometer. Just observe, they given distance meters, 300 meter distributor, but they given resistance per kilometer. So to convert kilometer into meters, right? Impedance section AC, ZAC, that is 0.2 plus j 0.1. What is the distance? 200 meter by 1000, that is kilometers. So that is 0.04 plus j 0.02 ohms, right? Next, impedance section CB, ZCB is equal to 0.2 plus j 0.1. What is the distance? 100 by 1000. So this is 0.02 j 0.01 ohm. Generally they in problem 0.2 plus j 0.1 ohm per kilometer. Now we have to cancel that kilometer with the help of distance. For 1 kilometer is nothing but 1000. ఇది ఈ సెక్షన్ యొక్క ఇంపిడెన్స్ డిస్టెన్స్ 200 కాబట్టి 200 by 1000. ఈ సెక్షన్ యొక్క డిస్టెన్స్ 100 కాబట్టి 100 by 1000. సో ఇంపిడెన్స్ ఆఫ్ సెక్షన్ ఏసీ 0.04 plus j 0.02 ohm and impedance of section CB 0.02 plus j 0.01 ohm. Now as you know that VB as the reference voltage, right? VB as the reference voltage. Now current at B, current at B is nothing but same current I2. I2 is equal to I2 cos pi 2 minus j sin pi 2. I2 200 cos pi 0.8 minus j sin pi 0.6. So calculate this one, 160 minus j 120 amperes. Now current at point C, that is I1. I1 cos pi 1, not F1, this is pi 1. I1 cos pi 1 minus j sin pi 1. I1 is nothing but 100. They given 0.707 minus sin pi also same. Then 70.7 minus j 70.7 amperes. Now current at points we have to calculate it. Now current at sections. Current in section CB in the same as I2, right? CB or I2 both are same. Already you have to calculate 160 minus j 120. Current in section AC, IAC is equal to I1 plus I2. I1 70.7 minus j 70.7, I2 160 minus j 120, like this. Now calculate impedance, calculate currents. Now calculate voltage drop in section CB. VCB is equal to ICB into ZCB. Then so this value is this one, 4.4 minus j 0.8 volts. Now voltage drop in section AC, VAC is equal to IAC into ZAC, similarly this value. Now voltage drop of the distributor, only voltage drop, not sending end voltage. Voltage drop is nothing but ఎంత డ్రాప్ వోల్ట్ అంతగాని రిసీవింగ్ ఎండ్ని యాడ్ చేయకూడదు. నేను 230 volts ఇచ్చాను, రిసీవింగ్ ఎండ్లో 210 వస్తుంది, మధ్యలో ఎంత డ్రాప్ వచ్చింది? 20 డ్రాప్ వచ్చింది. ఆ 20 డ్రాప్ VAC 10, VCB 10 అంతే. ఆస్కింగ్ డ్రాప్ మీన్స్ యూ డోంట్ యాడ్ రిసీవింగ్ ఎండ్ వోల్టేజ్. దే ఆస్కింగ్ సెండింగ్ ఎండ్ వోల్టేజ్, దెన్ వీ కెన్ యాడ్ రిసీవింగ్ ఎండ్ ప్లస్ డ్రాప్స్. అవుట్పుట్ ఈజ్ నథింగ్ బట్ ఇన్పుట్ ప్లస్ లాసెస్ కదా. సో సేమ్ డిట్టో. voltage drop is nothing but losses, VAC plus VCB. So like this, 17.44 minus J3. What is the magnitude of this one? 17.85, right? So most important problem, they don't change values also. 10 marks problem. Just calculate first impedance, next current, next voltage drops. Suppose they are asking sending end voltage, so plus receiving end voltage value, right? Similarly, next problem, ditto problem. మోహన్ రెడ్డి, మోహన్ రెడ్డి ఆడియో ఆఫ్ చేసుకోమ్మా. A single phase distributor 2 kilometers long supplies a load of 120 amperes at 0.8 power factor lagging at its far end and load 80 amperes at 0.9 power factor lagging at its midpoint. Both power factors are referred to the load voltage at far end. Voltages at far end, that is nothing but first one. Resistance and reactance per kilometer, here also per kilometer. If the voltage at the far end is maintained at 230 volts, they given receiving end voltage in this problem. Generally, before problem they don't given receiving end voltage. That's why they don't ask sending end voltage. Just they asking what is the voltage drop in the distributor. That is nothing but VCB plus VCA, VAC. Now they given far end voltage. Far end voltage is nothing but so receiving end voltage. Far end means దూరంగా ఉండే voltage అంటే లాస్ట్ లో ఉండే voltage. Voltage at the sending end, phase angle, both are asking. As usual, you have to write down the diagram. So 2 kilometers long ఉందంట, 120 amperes, 0.8 power factor lagging, మిడ్ పాయింట్లో ఉన్నాయంట రెండు కూడా. దట్ ఈజ్ నథింగ్ బట్ ఒక 120 amperes అనేది ఫార్ ఎండ్లో ఉంది, 80 amperes అనేది 120 amperes at 0.8 power factor is far end. Far end means last, that is B. I2 is equal to 120 amperes, cos pi 2 is equal to 0.8 lag, and 80 amperes 0.9 power factor is midpoint, that is the middle, that is C. AB is the distributor, let us assume, B is the far end and C is the middle point. I1 is equal to 80 amperes, 0.9 cos pi 1 is equal to 0.9 power factor, right? And the resistance, impedance per kilometer, they given per kilometer as usual, same. Impedance distributor per kilometer is 0.05 plus j 0.1 ohms, not watt, ohm. Now per kilometer value convert into ohms, so that's why, so impedance section AC, ZAC is equal to 0.05 plus j 0.1, so total 2 kilometers, and middle, that is nothing but AC is the kilometer అంటే 1000 meters, BC is also kilometer, that is 1000 meters. That's why 0.05 plus j 0.1, 1000 by 1000, where before problem 200 by 1000, 100 by 1000, but here exact middle, kilometer, 1000. That's why there is no change. Now voltage at point B is taken as the reference, that is why VB is equal to, they given 230 plus 230 volts, that is nothing but 230 plus J0. Now as usual, load current at point B, that is nothing but I2. Look at the figure, in figure పక్కన వేసాను చూడండి, AB, right, AB total 2 kilometers. సో మిడిల్ సి అనేది మిడిల్లో ఉంది కాబట్టి ఇది కిలోమీటర్ అంటే 1000 meters, ఇది కిలోమీటర్ అంటే 1000 meters. సో బి దగ్గర వోల్టేజ్ 230 volts ఇచ్చాడు, ఇక్కడ కరెంట్ వచ్చేసి I1 120, I2 120 amperes, cos pi 2 0.8 lag. So that's why now we have to calculate current at B, that is I2 120 into cos pi 2 0.8 minus j 0.6, the value is 96 minus j 72 amperes, right? Load current at point C, that is I1, So 80 into cos pi 2 minus j sin pi 2, this value 72 minus j 34.88. So current at points are calculated. Now current at section CB, ICB is nothing but I2, this one 96 minus j 72. IAC is nothing but I1 plus I2. 96 minus j 72 plus 72 minus j 34. So total value this one. To calculate the impedance at each section and to calculate the current at each section, now find out the voltage drops. VCB, ICB into ZCB, value is this one. VAC, IAC into ZAC, value is this one. Now sending end voltage VA is equal to, sending end voltage VA is equal to VB, that is nothing but far end voltage, VB plus VAC plus VBC. These two are the drops. VCB, VAC are the drops and sending end far end voltage is VB. The value is 261.08 plus J 17.45. Now magnitude, what is the sending end voltage in magnitude? Square root of 261.08 square plus 17.45 square, that is 261.67 volts. Now what is the phase angle between VA and VB is nothing but, so this one sending end voltage VA and VB. So what is the angle between these two is nothing but tan inverse of imaginary part by real part. So that value is 3.82 degrees, right? These two problems are very, very important. And they given, I am not putting in the slide, another problem is there. Let us just listen. Consider the single phase radial distributor shown in figure. Magnitude of load currents, power factor and distance are indicated in the figure. Resistance and reactance of each wire are 0.1 per kilometer, 0.2 ohm per kilometer respectively. It is required to maintain voltage at point B as 230 at an angle 0 degrees. Find the voltage drop in the three sections and total voltage drop in the feeder. Power factor angles of individual loads. అంటే ఇప్పుడు వరకు మనం మీకు నేను ఆ డెరివేషన్ చెప్పినప్పుడు కూడా రెండు సెక్షన్లే తీసుకున్నాను, అంటే సెక్షన్ 1 సెక్షన్ 2 మాత్రమే తీసుకుంటూ వచ్చాను. ఇందాక నేను ఎగ్జాంపుల్ చెప్పినట్టు శశి, చాణక్య, అదేవిధంగా మోహన్ రెడ్డి ఉంటే ఇంకొక సెక్షన్ కూడా యాడ్ అవుద్ది. అదేవిధంగా ఇప్పుడు ఈ ప్రాబ్లంలో కూడా సెక్షన్ ఏసీ బి అనేది లాస్ట్ అన్నాడు, బి అనేది లాస్ట్ ఉండాల్సిందే, అంటే ఈ మధ్యలో ఇంకొకటి పెట్టాలి, డి పెట్టాలి అంతే. మనం బీసీకి మధ్యలో డి పెట్టాలి. లెంత్ ఏసీ లెంత్ L1, సిడి లెంత్ L2, డిబి లెంత్ L3. సో వాడు వాల్యూస్ ఇచ్చాడు. 50 amperes VPF, 60 amperes 0.8 పవర్ ఫ్యాక్టర్, 40 amperes 5. యాజ్ యూజువల్ సేమ్ డిట్టో మనం ఎలా అయితే చేసామో సేమ్ అంతే, కాకపోతే ఇంకొక సెక్షన్ పెరుగుద్ది అంతే. VCD వస్తుంది అంతే, ఎక్స్ట్రాగా మనం VCD లెంత్ తీసుకోవాలి. I1, I2, I3 3 వస్తాయి అనమాట. ఆ ప్రాబ్లం కూడా నేను నోట్స్ ఇచ్చినప్పుడు చేద్దరు మీరు. అది ఇట్లా ఇంకెంతకు మించి ఏం అడగడు. ఆ 3 ప్రాబ్లమ్స్లోనే ఈ ఫస్ట్ 2 ప్రాబ్లమ్స్ ఎక్కువ అడుగుతున్నాడు. నెంబర్ ఆఫ్ టైమ్స్ అడుగున్నాడు 10 మార్క్స్కి. లేదనుకుంటే అడగడు, గమ్మగా వేరే టాపిక్ తీసుకుంటాడు. So this problem is goes to second one, that is power factor referred to respective load voltages. A single phase distributor on 1 kilometer long has a resistance and reactance per conductor of 0.1 ohm and 0.15 ohm respectively. At the far end, the voltage VB is 200 as usual. Current is 100 amperes, that is I2, 0.8 power factor, cos pi 2 0.8. At the midpoint M, distributor is current I1 100 amperes, cos pi 1 0.6 with reference to the voltage Vm at midpoint. Calculate voltage at midpoint, sending end voltage, phase angle between VA and VB. Right? So as usual, they are given directly. Distributor AB, middle point is M. That's why I am putting M. Otherwise, putting C. So total kilometer. That's why middle point is nothing but 500 meters. 500 meters. So total impedance of the distributor. Total impedance of the distributor. So the given impedance is 0.1, 0.1 plus J 0.15 ohm, right? 0.1 plus J 0.15 ohm. Total impedance. Total impedance is nothing but 0.1 plus J 0.15, 0.1 plus J 0.15, like the 2 into 0.1 plus J 0.15, that is 0.2 plus J 0.3. But this is not necessary. But work at impedance as usual. Impedance at section AM, ZAM is equal to 0.1 plus J 0.15 ohm, right? They given directly in ohm, not in kilometers. Before problems all are given ohm per kilometer, but this problem they given directly in ohm. That's why I am putting like directly. ZAM 0.1 plus J 0.15, ZMB also 0.1 plus J 0.15. That's why I am writing total impedance 2 into this value. Otherwise, by adding these two, getting this value only, right? No need to require this total impedance. Just impedance of AM, impedance of MB, and VB is the 200 plus J0. Now first one, load current at point B, that is I2 cos pi 2 minus J sin pi 2, that is 80 minus J60. Now current in section MB, that is nothing but I2, 80 minus J60. Now voltage drop section MB, VMB is equal to IMB ZMB. The value is like this. Now voltage at point M, VM is equal to, they are asking first question, voltage at M. Voltage at M is nothing but, look at the figure once again, voltage at M is nothing but this drop VMB plus VB, VMB plus VB. So VB already given 200, and VMB, this is the 17 plus J6. Now by adding the 200 plus J0 plus 17 plus J6, 217 plus J6, and magnitude is square root of 217 square plus 6 square. The value is 217.1 volt. So this is the voltage at midpoint M. And now you have to observe VM is nothing but one consumer, VB is nothing but another consumer. They will calculate their own individuals. Now calculate alpha value, phase angle. Alpha is equal to tan inverse of 6 by 217, so 1.58 degrees. Now VB having their own power factor, that is 0.8 power factor. VM they having 0.6 power factor. Now total combined angle, so this is 1.58. Now subtract from that power factors to this value. That is the only difference compared to remaining problems. So as usual, pi 1 cos inverse of 0.6, 53.13. Therefore pi 1 dash, pi 1 minus alpha, 53 minus 13 minus 1.5. అర్థమవుతుందండి. ఫస్ట్ మనం ఇండివిజువల్ పవర్ ఫ్యాక్టర్ వాడు ఇచ్చేస్తున్నాడు. ఇప్పుడు మోహన్ రెడ్డి పవర్ ఫ్యాక్టర్ ఇచ్చున్నాడు, అదేవిధంగా చాణక్య పవర్ ఫ్యాక్టర్ వాడు ఇచ్చున్నాడు ఆల్రెడీ. సో ఇప్పుడు మనం వాళ్ళిద్దరు లోడ్ కలిపి ఒక వాల్యూ కనుక్కో, ఒక యాంగిల్ కనుక్కున్నాం. దట్ ఈస్ ద ఆల్ఫా వాల్యూ. నౌ ఇప్పుడు ఆల్ఫా వాల్యూ ఎంతో కొంత వచ్చింది. ఇప్పుడు చాణక్య దాంట్లో నుంచి ఆల్ఫాని తీసేయాలి, చాణక్య యాంగిల్లో నుంచి ఆల్ఫా యాంగిల్ తీసేయాలి, అదేవిధంగా మోహన్ రెడ్డి యాంగిల్లో నుంచి కూడా ఆల్ఫా వాల్యూ తీసేయాలి. ఇప్పుడు చాణక్య యాంగిల్ ఎంత? pi 1, దట్ ఈస్ కాస్ ఇన్వర్స్ ఆఫ్ 0.6, 53.13. pi 1 డాష్ ఈజ్ ఈక్వల్ టు pi 1 మైనస్ ఆల్ఫా, 53.13 మైనస్ 1.58. Right? So this is pi 1 is 53.13 is the individual Chanakya angle, and this one total load angle. So total value is new angle is 51.55. Similarly, now find out current. Once angle is find out, now find out current at I1. I1 cos pi 1 dash minus j sin pi 1 dash. Value is like this. So whenever find out the current at section AM, IAM is equal to I1 plus I2. Whenever find out the current in section, voltage drop in section, VAM is equal to IAM into ZAM. Value is this one. Therefore sending end voltage VA is equal to, look at the picture, sending end voltage VA is equal to VAM VMB plus VB. The value is 252.32 volts. So you have some doubt, sir. You say that VA is equal to VAM plus VMB plus VB, right? So what about VM? VM is nothing but that is the value. Already you have to find out na VMB plus VB. Voltage at point M is nothing but, so VB plus VMB. Extra ga VAM add cheste sending end voltage. That's why here putting VM plus VAM. Value is 252.32. Phase angle is nothing but tan inverse of 13.5 by 251.96. That is tan inverse of 0.05358. That is 3.07 voltage. Therefore sending end voltage is 252.32 and phase angle is 3.07 volt angle. Arvind sir వచ్చున్నాడమ్మా. Right? So like that you have to determine the respective load voltages. Only one difference, and everyone will confuse this one only. అందుకే తెలుగులో చెప్పేది నేను ఫస్ట్ ఇండివిజువల్గా మనం వాళ్ళ యాంగిల్స్, ఇండివిజువల్ కన్జ్యూమర్ యాంగిల్స్ ఇచ్చేసి ఉన్నాడు. టోటల్ లోడ్ యాంగిల్ మనం ఫైండ్ అవుట్ చేస్తాం. ఆ తర్వాత ఇండివిజువల్ యాంగిల్ నుంచి లోడ్ యాంగిల్ తీసేసిన తర్వాత దెన్ వీ హ్యావ్ టు ఫైండ్ అవుట్ ది కరెంట్, రైట్.